Hi everyone. We're going to be taking some new notes today on compound interest. So compound interest is very similar to the exponential growth and decay equations that we have been talking about. Compound interest, the formula is a type of exponential equation, and really you use it whenever you're talking about a special case. So if we start here with this first line, this is the special case in which I'm referring to. So compound interest occurs when interest is calculated on both the initial amount and the interest earned thus far. So when we talk about interest, that is usually a percentage which can be compounded annually, right, yearly, depending on whatever factors the word problem is giving you. So let's jump right into the formula. Let me change the color. So the formula for compound interest, whenever you're working with a compound interest exponential equation, is this below. Y is equal to A times the quantity of 1 plus R divided by N, and then all of that raised to the power of N times X. So this one, if you think back to the exponential growth and decay word problems we were working with, the formula looks very similar. However, we do have some new and added variables into our equation. We're going to talk about what those variables are in a second. So let's start with the first variable. A does not change. A still represents the initial amount, which the word problem gives you. R is still going to represent a rate, and in this case, they're going to be interest rates. N is the new one, is the new variable. N represents the number of times the interest is going to be compounded, and this is on a yearly basis. So interest can be compounded. There's different types. That can be just once a year, right? It can be quarterly, it can be semi-annually, it can be monthly, right? Those all represent interests which can be compounded a certain amount of times per year. And that number which is happening per year, that's going to represent our N variable. And then X does not change. X represents the amount of time which the word problem is giving you. So now that we know what these variables represent, we're going to go ahead and work on an example. All right, so let's go ahead and let's work on example number 1. So example 1 tells us that Laura deposited $12,000 into an account that earns 8% interest. How much money will she have in 5 years if the interest is compounded quarterly? So what we notice with these problems is that now we're going to have this factor of the interest rate being compounded at different rates. In this case, it's telling us it's compounded quarterly. So we need to be able to figure out, what does it mean if an interest rate is compounded quarterly? We're going to get there in a second. Let's go ahead and start with the other variables that we know right off the bat. We can identify what the values are, and we'll talk about what compounded quarterly, how that's going to affect our word problem. So again, we know that's the formula that we're going to use up at the top. So let's identify. What is my A value here? My A value, remember, represents the initial amount. So the initial amount of money, which I'm talking about in this case, is $12,000. So my A value is $12,000. My R value is my rate. So in this problem, the interest rate is going to be 8%. But remember, those interest rates, you have to convert them into a decimal point first. So 8% represented as a decimal would be 0.08. I saw a lot of people making errors last week converting percentages into decimals. If you are still confused about that, make sure you ask me. Remember, that decimal point that is really right here, it needs to be moved over twice. So if there's a number up in the front, you will not necessarily have that 0. It all depends on the percentage that's being given to you. So with that being said, again, if you're still confused, make sure to ask. let's move on to the next the next variable, n. So n represents, if we look up here at the top, it represents the number of times compounded annually. So this interest, it tells us that in this case, in example 1, this interest is compounded quarterly. So quarterly, what does that mean in regards to the number of times per year? Think about it. Quarter. There's the root word in there. Quarter means 4. So this interest is going to be compounded 4 times per year. So that means that my n value is 4. And then lastly, the amount of time which this word problem is asking us for is how much money will she have in 5 years. So my x value would be 5. Now that we have identified our a, our r, our n, and our x values, we can go ahead and substitute them into our formula. All right, so as a reminder, when we are working with compound interest exponential equations, this is the formula we want to use. So now that we have identified our variables, let's go ahead and just substitute them into our equation. So y is going to be equal to, my a value in this case is 12,000, multiplied by 1 plus r divided by n. So that would be 0.08 divided by 4. And then make sure to close those parentheses. You have double parentheses now. All raised to the power of n times x. So that would be 4 times 5. All right, that is us just substituting the values from the word problem into the formula. Once you have done that, you use algebra, you use your order of operations, and you use a calculator to then help you simplify this answer as much as you can. Obviously, we're going to go ahead and work with inside parentheses out, right, as our order of operation tells us to do. So we're first going to work with this. We need to do 0.08 and then divide that by 4. So I'm going to open up my calculator. I'm going to take 0.08 and divide that by 4. I get 0.02. And then remember, I have to add 1 to that. So then I would do plus 1, which gives me 1.02. So everything inside this parentheses would simplify down to, let me change back to my pencil. So my 12,000, I haven't multiplied that out. So I would have 12,000 times everything in this parentheses simplified down to 1.02, all raised to the power of 4 times 5 is 20. So what I next want to do is work with 1.02 raised to the 20th power. So on my calculator, I have my 1.02, and then I'm going to raise it, so pressing this key, raise it to the power of 20, which gives me that really big number, and then that really big number needs to be multiplied by 12,000. Which is going to simplify down to approximately 17,831.37 if we round up there. So then all of this would simplify down to 17,831.37. And that represents the amount of money that Laura will have in 5 years if she originally deposits $12,000 and then earns 8% interest 4 times per year. Remember, the whole thing with this word problem is that we know that Laura is getting compounded quarterly. So 4 times a year, she is going to get that interest rate being added to her account. All right, so Let me know if you guys have any questions. Like I said, these are very similar, however, slightly different because you have that compounded interest to be considered now. And remember, they might not always ask you for quarterly. Let's say I'm going to do some little scratch work off here to the side. Oops, 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 oops. I did not mean to do that. Let's do some scratch work over example for here. So let's say that rather than quarterly, the interest is compounded semi-annually. So if it was compounded semi-annually, that means that it would happen 2 times per year. So in this case, n would be equal to 2. What if it tells you that the interest is compounded monthly? That means that the interest is going to be compounded 12 times. So n would be equal to 12. Remember that compounded interest depends on a yearly basis, right? That's what it says right here, on a yearly basis. So this is why in the original problem, the original example 1, it was compounded quarterly. So my n value was 4. There are 4 quarters, right, in a year. If the problem told you that it was compounded annually, your n value would then change, semi-annually, it would change to 2, because semi-annually means that it's going to happen twice per year. If it were to be compounded monthly, that means that there are 12 months in a year, so then that interest value would be compounded 12 times per year. So what's really going to change in these problems, and what you have to be very mindful and careful of, is that compound interest rate. All right, let me know if you guys have any questions, and we will keep in touch. Bye.